In this example, I want to demonstrate compounding more frequently than once a year using the formula and also the financial calculator. Initially, though, let's just pretend we've got $100 and we're going to invest it for a decade, and the rate that we're earning is 12% compounded annually. So I'm just going to put CA, compounded annually. To determine the future value, using the equation, I'd take $100, which is my present value, times 1 plus I being 0.12, to the power of n is 10, and I'd solve for the future value. My interest factor right here is 1058. Multiply that by 100, and that gives me $310.58. Now, if instead of compounding the interest annually, it was 12% compounded monthly, I'll go ahead and write that monthly out just to emphasize that that's what's changing. And I still keep my money in the bank for 10 years, how much would I have? Well, it's going to be more because I'm going to be receiving interest once a month rather than once a year. Although I'm not going to get 12% a month, I'm going to get 12% divided by 12 months, so I'll get 1% in interest per month. Using the formula, I'm going to go ahead and write the formula out. It's future value equal present value times 1 plus I to the n. When you use the formula for more frequent compounding than annually, what you need to do is adjust your n. Your n becomes the number of compounding periods in the entire time period that we're talking about. So if we're receiving interest compounded once a month, it's being compounded 12 times a year times 10 years. So our n would be 120. And our I, instead of being the annual I, becomes what they call the periodic I. How much are you receiving in interest as a rate per month? Well, we're getting 12% annually, but it's being compounded once a month, so we're getting a rate of 0.01 a month. So this would be 1.01 to the power of 120. Is our new interest factor, and we'd multiply that by the present value of 100. My interest factor changes from being 3.1058 to 3.30, so you can see it has gone up. Take our interest factor, multiply it by our $100, and our future value would be $330. So we're getting about an extra $20 because our interest is being compounded monthly rather than annually. Now, on the financial calculator, I'm going to go ahead and just write it using our time value of money keys. We'd use the TVM solver like I've talked about before, or our TVM keys, depending on which model calculator you have. Now, some of you have these special P/Y and C/Y keys that show up on the screen, and normally I ask you to keep these set at 1. The reason I do that is when I first started using financial calculators, you didn't actually even have the ability to change the payments per year, but over time they made calculators where you could change it, but it wasn't on the display. And so I would change mine and it'd store it in memory. I couldn't see what it was set at, and I would forget that it was set to something other than 1, and I would work a problem where it should have been set on 1 and I'd get the wrong answer. So just as a habit, I started doing what I call manually adjusting my N and my I, and I always leave my P/Y and C/Y set to 1. You don't have to do it that way, but when I work problems for demonstration purposes, I'm going to leave these fixed at 1. I have tried it the other way with the newer calculators, and I just find it simpler to do it the way I'm showing you. So to manually adjust your N when you've got compounding more often than once a year, what you do is you take your normal N, in this case that would be a 10, and you multiply it by how often interest is compounded. So our N would be 120. With your I, you take your normal I, your annual I of 12%, and you divide it by how often a year interest is compounded, so 12 months. So we're getting a 1% rate for 120 time periods. Our present value would be 100. There wouldn't be a payment in this example, and we'd solve for future value, and we should get 330. Again, it'll give you a negative 330 if you entered a positive 100.